or sometimes people will refer to them as composite functions, refers to the combining of functions, where the output from one function becomes the input for the next function. So basically, like, the answer you get from one is what you're going to plug into the next one. Essentially, you're inserting one function into the other, and sometimes you can do this for a given value, so like you'll plug in a number, and then sometimes you will do this just with the functions themselves. So there's two different notations that you're going to see for composition of functions. You might see this one that looks like fog, f, and then there's like a little circle, g of x, or you might see it as f parentheses g of x. In both situations, it's read as f is composed with g of x, or I will usually read it as just f of g of x. So wherever you see the little circle is where you're going to say of, or whenever you see like the parentheses is where you're going to say of, f of g of x. So what this literally means you're taking the g function and you're plugging it into the f function. So you see how g is like inside f's parentheses? So that means you're taking the g function and plugging it into the f function, or just based on whichever function is in the inside part. So we're given two functions on the next section using f of x is 3x plus 5 and g of x is negative x squared minus x. The first one is just regular notation. It says, you would read this as g of f of 2, g of f of 2. So I'm going to start by doing the inside part first. I'm going to start with doing f of 2 first. Step 1, find f of 2. F of 2 equals, and then I'm going to take that 2, remember we're plugging that in for x, in the f function, So we'll have 3 times 2 plus 5. That becomes 6 plus 5, and 6 plus 5, remember, is just 11. I believe I had this exact question on in other notes. So remember, a composition means the output you get from one, which is 11, is now going to become the input for the next one. So now that we did f of 2, now we're going to do g of the answer that I got. So it would be g of 11. So g of 11 is going to be negative and then 11 squared minus x. So we're basically using 11 as the x value for the g function this time. So we'll have negative 11 squared minus 11. Remember, when you do this, you're going to do a little PEMDAS. If there was something to do inside the parentheses, you would do that first, but there's nothing to do inside our parentheses. So we're going to start by just squaring. 11 squared is 121. So it's become negative 121 minus 11. Technically, you don't need the parentheses right here. It would just be literally negative 121 minus 11. Negative 121 minus 11 is negative 132. 132. So this would be g of f of 2. Proper notation for final answer. So it's basically work out one, then work out the other. Work out one, work out the other. I'm going to do the one on the right-hand side next, this one that looks like fog of negative 1. Okay, so remember, this is equivalent to saying, I'm going to write its other notation. So we would have f of g of negative 1. I like the notation that has it like showing which one is substituted into the other one, but College Board likes the one that says fog, so I got to show you both of them. So again, which part of this one are we going to do first? Inside, right. We're going to do g of negative 1 first. That means we're going to take the g function and plug in what? Take the g function and plug in what? Negative 1. Very good. So I'm going to start by doing g of negative 1. So that's negative and then negative 1 squared minus negative 1. So basically, here was the x and here was the x. Be careful when you simplify on this one. It's got a lot of positives and negatives going on. Which part am I going to do first? The exponent. What is negative 1 squared? 1. So then this would become negative and then a 1 in the parentheses minus negative 1. Okay. Negative and then times the 1 in the parentheses. That's just negative 1. And then what would be negative times negative 1? plus 1. Getting a final answer, g of -1 of 0. Very good. Okay, and then once we have that answer, remember that becomes the input for the other function. So now we're going to do f of that answer. Then do f of the answer that we just got, which was 0, which means we're going to take 0 and plug it into which function, f or g? F. Very good. So that one only has one variable, so it would be 3 times 0 plus 5. That's mental math. That is 5. So my f of g of -1 just becomes a final answer of 5. My fog of -1. All right, on your whiteboards, everybody grab a whiteboard. Whiteboard, 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 and a marker. Extra markers are always up here if you could get a dry marker. Yeah, everybody has 2. Okay, on your whiteboard, I'm going to have you do f of g of 3. F of g of 3. Okay, just kind of reminding you, that's equal in the other notation to having f and then a big parenthesis and then g of 3 in the smaller parenthesis like this. Same notation. Final answer. Let's take a minute, see if we can get that answer on your whiteboard. Oh, those dang buses. Which one are we going to plug into first? G. Plug into G first, right. Do we need extra time? We have 5 seconds left. Do we need 30 more seconds? 30 more seconds. Okay, 30 more seconds. I'll just set a minute timer and then wait till it goes down to 30. $20 more seconds. All right, that's our 30 seconds. Boards up, boards up, boards up, boards up. Ooh, lots of right answers. Correct answer was -31. -31. If you didn't get -31, let's do it together. Your first step would be to do g of 3. Plugging in 3 to the g function, that's negative, and then 3 squared minus 3. That would become -9 minus 3. And what's -9 minus 3? -12. Okay. And then after that, then you'll do f of the answer. So then do f of -12. That's 3 times -12 plus 5. That would become -36 plus 5. And -36 plus 5 is -31. All right, bottom questions. Bottom questions, notice they don't give us a number on these two bottom questions. They just say f of g of x, and then this one says g of f of x. If they don't give you a number to plug in, you are literally just plugging the function into the other function, like the actual equation part of the function. So f of g of x right here, this is literally telling you to take g and plug in g to the f function. Okay, so all of g, this whole output of g, is going to get plugged in to the f function in place of its variables. So I'll show you what that looks like. I'm going to use a separate color so you kind of see it. So I'm going to have 3, and then where the x is in the f function, So here's where the x was, 3x plus 5. We're going to put the entire output of the g function, which was negative x squared minus x. And then we're going to simplify. So again, this is our g function that we've plugged into the f function. Just a tiny little bit of simplifying you can distribute right here. 3 times negative x squared would become negative 3x squared. 3 times negative x would become negative 3x. And then we'll bring down our plus 5. Can I combine any more? No, no more like terms. So we've officially did f of g of x. We took g, we plugged it into f. F of g of x. Okay, we're gonna go we're gonna go the other way on the second question. Okay, we've got g of f of x. Remember, I like the other notation, so I always write what that's equal to in the other notation. So we'd have g and then a big parenthesis, and then f of x inside that parenthesis. College Board likes the one with the fog, so I like to throw it in every now and then. So g of f of x means we're going to take f and plug it into the g function. I'll write that down. Plug in f to the g function. I don't have room to write function. Plug in f to the g function. It's not as much fun to go this direction. You'll see as we start doing it, it's not as simple as like, oh, just distribute your 3. So I'm going to take all of f, and this one actually has 2 places to plug it into in the g function, so where both the variables are. So that'll be, we'll have negative, we'll open a parenthesis where the x was, squared minus, we'll open another parenthesis where the x was. Both of these places had x's, so what are we going to put in their spot? What goes in their spot? The f function. And what was our f function? 3x plus 5. 3x plus 5. 3x plus 5. Which part of this would we need to simplify first? The square, yes. Now we've talked about it last week, but let's see if we remember. Can we just square 3x and square 5? What do we need to do? Foil it. You can foil it on your whiteboard if you don't want to mess up your paper. I'm going to use a little separate paper like this. 3x plus 5 times another 3x plus 5. First times first would become 9x squared. Outer times outer would be 15x. Inner times inner would be another 15x. And then last times last is 25. And then what would those 15x's combine to in the middle? 30x's, right? All right, I'll transfer this back over to my paper. I'm going to still keep it in parentheses because we do still have that negative in front. So 9x squared plus, sounds of nature, minus, and then we have 3x plus 5 on this one. Oh, hi. Can I help you with?
This is my first day.
All right, pick a chair. All right. What do we got next? Multiply by the negative on both parentheses. Both parentheses show us multiplied by the negative, so we're going to take that negative and distribute all the way across. I'm going to have you guys finish this one on your own now that you can see, oh, that negative needs to be distributed here, that negative needs to be distributed here. So your job will be to distribute the negative, combine like terms, and then we're going to ink, pair, share with our partner. Distribute the negative, combine like terms, and then we're going to ink, pair, share with our partner. I'm doing 1.5 minutes for us. Distributing that negative, combining our like terms. 2 seconds, 1 second. All right, let's have pink share with purple, yellow share with green. What was that final answer you got when you distributed and combined? All right. Final answer should have been negative 9x squared minus 33x minus 30. Did y'all get that? Okay. When you distribute the negative, that would be negative 9x squared minus 30x minus 25. When you distribute this negative, it would become negative 3x minus 5. And then some like terms you have, let's see, negative 30 and negative 3 becomes negative 33. Negative 25 minus 5 becomes that negative 30. Did we get the same answer when we did f of g of x and g of f of x? No, one was significantly harder. So it doesn't, you're not going to get the same answer depending on which one you plug into which one. All right, bottom questions from AP Classroom. It's a multiple choice question. It says, if f of x is 2x minus 1 and g of x is x squared plus 1, which of the following equations defines function, how would I read this again? Not technically fog, we read it as f of g. And notice they don't give you a number to plug in, so you will just be plugging in the function. All right, I'm going to give you guys, let's do a minute and a half again. I think that was a decent amount of time. Actually, this one's easier. You probably only need 1 minute. 1 minute to do this one. I'm going to have you put your final A, B, C, D on a whiteboard. So 1 minute to do f of g, and then final answer goes on a whiteboard. If you want to look back up at the notation at the top, what f of g means, like which one's plugging into which one, and then just on your whiteboard will be A, B, C, D. Yes, just A, B, C, D on the whiteboard. Do we need 30 more seconds? 30 more seconds? Or we got it? Y'all got it? Everybody got it? All right, boards up. Boards up, boards up. Beautiful. It was B. Good job. In case you couldn't figure it out, f of g like this, f is you're going to open a big F and then say g of x inside. Okay, so that literally means we're going to take the output for g and plug it into f in place of it's just one variable. Yay for only one variable to plug it into. So that would become 2. In place of the x, we would have x squared plus 1. And then we'd still have this minus 1 back here. If you distribute the 2, it becomes 2x squared plus 2 minus 1. And then combining the two like terms at the end, it would become 2x squared. 2 minus 1 would be plus 1, which is B. All right. Flipping it over, what do we got on? Oh, we can do it with graphs. Remember we did this same thing with operations. Not only can you do function operations with graphs and tables, you can do function compositions with graphs and tables. This one's kind of word problem-y, so I'm going to have us just annotate real quick. It says function f is defined on -1 is less than or equal to x, which is less than or equal to 4. Anytime it says defined on, that literally means it only exists from -1 to 4. It does not keep going. It only exists from -1 to 4. Function g is defined on 0 is less than or equal to x, which is less than or equal to 4. So again, that also means g, which is this one over here, is only defined from 0 to 4. It does not keep going. There's no arrows. The graphs of y equals f of x and y equals g of x are shown in the xy planes. Can you see which one is f and which one is g? Okay. just in case we can highlight, this one is F, this one is G. Okay, I'm going to do the first one with you, just in case you don't remember how this works with a graph. So it says G of F of 0, G of F of 0. So we're going to start by doing the inside part first, F of 0. F of 0 equals, let's go find it. So we're going to look on the F graph for the output when the x is 0. So on the F graph, here's where x is 0, here's where it is. What would that be as an ordered pair? 0, 2. So what are we going to write down for F of 0? 2. Right, F of 0 is 2. And then once we know F of 0, we're going to do G of that answer. Then do G of 2. So I'm going to go look on the G graph, that's the one to the right, for an x value of 2. I'll find it. Here's an x value of 2 right here. We'll see what point that is on the actual graph. That is the point 2, 8. So what would I write down for G of 2? G of 2 is 8. Very good. Equals 8. So my whole entire final answer would be the last one. G of F of 0 is 8. For the middle one, again, I'm going to write that in the other notation. This is the College Board notation, G of F of -1. I'm going to convert that and say G and then put a big parenthesis of F of -1. Same thing. What are we going to find first? F of -1. F of -1. In your group, see if you can find F of -1. What is F of -1, gang? Okay. Everybody got an answer? Show me on your fingers. What is F of -1? It is 4. Good job, because you can see over here, -1, 4. Equals 4. And then once we have that answer, what's our second step? Plug it into G. Very good. So then we'll do G of the answer that we just got, G of 4. Let's go look on the G graph. G of 4, look, everybody see it? Everybody say it out loud. What is G of 4? 0. You can see it right here. 4, 0. G of 4 is 0. So my final answer for G of F of -1 is that 0. Alright, I'm going to have you do a table talk for the last one. Table talk. What are we going to write? Let's take a minute. Let's talk about it. What in the world are we going to write? It is kind of weird. Let's talk about it in our groups. Alright, I'm going to have, Jose, can I have your group tell me what you wrote for this answer? For F of G of 1? What'd y'all write? It is undefined. Undefined. Let's look at why. If I did G of 1, does G of 1 have an answer? Yes. G of 1 is 6. It's right here. Okay, so then I would have to do F of that answer, F of 6. Do we have an F of 6? According to the directions, are we allowed to continue it on? No, because it says it's only defined on -1 to 4. So if this is not defined, you would just say not defined. You could say not in the domain. That also works too. In a, none. Any of those will work. F of 6 was not defined. Which you get every now and then you get one that doesn't have an answer. All right, looking at the middle section. Again, we had tables like this on Friday when we did function operations, where we were adding and subtracting them. Functions f and g are shown in the table. Do y'all remember how this table worked when we saw it on Friday? You have the x values over here on the left side. Both functions have the same x values. And then you have the output for f in the middle column. So these are the y values for the f function. And then you have the output for g in the right-hand column. So these are the y values for the g function. Okay. Do y'all want to do these in your group? Remember how these work? Okay. I'm going to have you do these in your group, and then I want both answers on a whiteboard at the end of 2 minutes. So at the end of 2 minutes, both answers are going on a whiteboard. Talk to your tables. What'd you get for this part? What'd you then do? You can say that. I'm okay with it. Alright guys, let's throw those boards up. Let's see what final answers were for both. Dang it, I should have made it 6 and 7. What was I thinking? Yes, 3 and 5 are the two answers. If you didn't get that, Brian, you getting this part, hon? If you didn't write it down now, hon. G of 2 is 1. And then you would do f of 1, which is 3. So that final answer would be 3. And then for the second one, you'd start by doing f of 5, which is 1. And then you do g of 1, which is 5. So final answer would be just 5. G of f of 5 is also 5. Okay. Bottom question. I snagged this from AP Classroom, and it hurt my brain when I did it. So it's going to hurt your brain too. But we're going to survive. How much time they covered up my timer. Okay. A word problem. Yay, what should we do? Annotate. Annotate. And put a little hashtag. What are we trying to find? Hashtag. What? Computer store is having a sale. The sale is offering a 20% discount on prices of computers. Okay, decent discount. The store is also offering rebates of $35 off the prices of the computers. The function f models the price of a computer after the discount, and function g models the price of the computer after the rebate, where x is the original price of the computer, Which of the following represents the final price of a computer if the discount is applied and then the rebate is refunded? If the discount is applied and the rebate is refunded. Okay. Hashtag, we're trying to determine the function. I guess we're just writing the function. Hashtag find the function. Actually, we're trying to figure out if it's a function operation or composition according to the answers. First thing I'm going to have us do is just write the two functions that would represent these things. We're going to write f of x, and we're going to write what g of x is. G of x. Okay. So f of x, if we get a 20% discount, how do we write an equation showing that we got a 20% discount? 0.8 times the original price. Yes. 0.8 times the original price. Because this shows, like, if you get a 20% discount, that basically means you're paying 80% of the original price. Okay. And then for my g of x is basically whatever my discount price was. Discount price. And then how much am I getting as a refund? How much am I taking off? Minus 35. Minus 35. So we want to figure out which of these would represent that final price. F of x minus g of x minus f of x, f of g of x, or g of f of x. Let's talk in our tables just for a minute, see if we can figure out which one it is based on the fact that we kind of have an idea of the two functions. Again, this one does hurt brains. It's okay to have your brain hurt. What doesn't kill you makes you stronger. Let's talk for a minute. Which one should we choose? Right answer? Alright, I'm going to do a quick response. Basically, I want you to show me with your fingers. 1 finger if you thought it was A, 2 if you thought it was B, 3 if you thought it was C, 4 if you thought it was D. What do we think it should be? What should it be? It is 4-finger D. Yes. Because it was this part right here that kind of gave it away. It's like you have to know the discount price because you're going to take that discount price and plug it in here. So if F gets plugged into G, it's this one. F is getting plugged into G. Alright. What time is it? DOL time. We have exactly 10 minutes. It's 9:05.